Chapter 6, Section 4. In this section, we're going to learn how to change exponential statement to logarithm statement and vice versa. Okay, how to change logarithmic statement to exponential statement. And then we need to learn how to evaluate logarithm expressions and determine the domain of the log function and then graph log function, and then eventually we learn how to solve the log equations. So now let's look at the definition of the logarithmic function with base a, where a is a positive number and a is not equals to 1. Okay, and then denoted by y equals log a as the base of x. Okay, that's read as y is the logarithm with base a of x, and is defined by this if and only if x equals a raised to the y's power, and the domain of the log function is x must be a positive number. Okay, x must be a positive number. So when we look at this definition, it looks like a very confusing at a first glance, right? So in order to help you to digest this definition, I just want you to remember a chant, which is a log is an exponent. Okay, so if you wonder what is the log function, what is that? So that's just indicate, it's an exponent. Okay, or in other words, y equals log a as the base of x. Okay, this is equivalent to this expression, which is x equals a raised to the y power. Okay, these two expressions, they are identical. Okay, they're equivalent. So we learned the exponential function, in the previous function, in the previous section, right? F of x equals c times a raised to the x power, right? And then we also learned the one-to-one function, and we learned the inverse function. So log function actually is the inverse function of exponential. All right, so remember inverse function, basically just xy swapped, right? So define the log function actually is defined based on the inverse function of exponential. All right, so if you look at the base, okay, in log function, the base is a, right? In the exponential function, the base is a, right? And then in the log function, this is x, and then output is y. But in exponential, y is the exponents, x is the output. Did you see just xy switched? Okay, so that's, we define the inverse function of exponential, okay, by the log function, right? We define, we define log function as the inverse function of exponential. So that's why you just need to remember a log actually is an exponent. All right, so let's try some example, just help you to understand that. Okay, so first, how can we change from exponential statement to the log statement and vice versa? Okay, so let's give it a try. 1.3 raised to the third power equals m. Okay, remember the chant, a log is an exponent, right? So here, what is exponent? 3, right? So log is an exponent, right? So log is the exponent, which is 3. So what is the base of exponential? It's the same base with the log. That's 1.2, and then of m. Okay, that's how we write this exponential form to the log. Okay, make sure the exponents, that equals the log. Right? And the same thing here. The exponents, which is b, equals the log. Log, what is the base? Same base as exponential, so e as the base of 9. Okay, that's how we write. So remember, log is an exponent. Okay, log is the exponent. B is the exponent, right? And the same way, exponent is a 4, so that's the log, right? Log is an exponent, so what's the base? Log base and exponential base is the same, so that's an A. And then of 24, that is the exponent 4. All right, that's how we changing exponential statement to the log. All right, now let's do change the log to exponential statement. Okay, so remember, a log is an exponent, right? So 5, it will be the exponent, right? That's how we write into exponential, right? The log, right? This is the log, right? Is the 5, so 5 will be the exponent. So same base, right? Log base, exponential base should be the same. So A raised to the 5th power equals 4. And the same here. Same base, right? E to the exponents, right? Negative 3 equals B. Okay, here base is 3, and the exponent is the log, right? Is the C is the exponents, equals 5. All right. So how to evaluate the logarithmic expression? Let's give it a try. So if we want to evaluate a log, and then we can, convert it to the exponential. Okay, convert to exponential and then solve from exponential equation. All right, so if we try to find the exact value, and then we can let that be x or be y, okay, just set it to be any variable, okay, whatever the variable you can use. Okay, I just use x, book maybe use y. So we just let this expression, okay, to be certain variable, okay. So I just use x to represent, and then rewrite this log as the exponential form. Okay, so remember that's the exponents, right? Log is an exponent, so x is exponents. So 2 is the base, x is the exponents, equals 16. Right? So we just like convert solving a log back to solving an exponential equation. And then remember, solving exponential equation, what is the rule? The two exponential with the same form, if they're equal, and then the two exponents are equal, right? So we just need to rewrite 16 as exponential form with the base 2. So we figured 2 raised to the 4th power equals 16, right? So now can we solve the x? X equals 4, right? Or what is x? Log 2 as the base of 16 equals 4, right? And the same way, if we let this be x, that's what we're looking for, right? And then we write back to exponents. So, I'm sorry, x is the exponents, right? 3 raised to x power equals 1 over 27. So again, we convert the log expression into solving an exponential equation. So 3 to the x right hand side, we need to also write as exponential form with the base 3. So think about 3 raised to how many power equals 1 over 27. 1 over means the negative sign, right? So 3 raised to how many power equals 27? Third power, right? So that's negative 3 power. 3 raised to the negative 3 power equals 1 over 27. So now two exponential with the same base, they're equal. That indicate two exponents must be equal. So x equals negative 3. So what is x? That's the log 3 as the base of 1 over 27 equals negative 3. Okay, that's how we find the value, exact value of the log expression. So what we did is convert it to the exponential equation and solve.